Asteroids, volcanoes, a lack of oxygen, these were just a few of the forces that almost wiped out life on Earth, yet, against all odds, humans survived and thrived. But how did we go from tiny molecules to the dominant species on the planet? Let's take you on a journey through time, one that explores the fascinating evolution of humans. Along the way, we'll meet LUCA, a distant relative we all share. We'll also answer the question, is it evolution's fault that many of us are stuck wearing braces today? And here's a mind-blowing thought. Could we all share the same ancient grandmother? 4.2 billion years ago, something incredible happened. And no, it wasn't the Big Bang. This was the start of abiogenesis, the process where life began from non-living matter. Picture this, a primordial soup of ammonia, methane, and hydrogen, stewing in a hot broth of water near a volcanic vent deep in the ocean. Instead of spices, Mother Earth added sulfur, nickel, and iron. Over millions of years, these ingredients mixed together, forming amino acids like lysine and lactic acid, the building blocks of life. Somehow, some of these molecules started replicating themselves, and just like that, life on Earth was born. Simple molecules transformed into the very first single-celled organisms. Meet LUCA. This is where LUCA comes in, the last universal common ancestor. LUCA is the distant relative of every living thing on Earth, from humans and animals to fungi and trees. Unlike us, LUCA wasn't aware of its existence, but it paved the way for life as we know it. Even though we know a lot about how our species evolved physically, from developing large brains to walking on two legs, the leap to self-consciousness is still a bit of a mystery. Some philosophers suggest that psychedelic mushrooms might have played a role unlocking human consciousness. The theory suggests that ancient ancestors who consumed these mushrooms began to develop language, self-awareness, and social bonds, the traits that make us human today. Oxygen. The key ingredient before humans could enter the stage, the Earth needed one crucial ingredient, oxygen. Early Earth's atmosphere was full of nitrogen, hydrogen, water vapor, and carbon dioxide, no good for us. But thanks to cyanobacteria, oxygen slowly started to fill the air, making Earth a habitable place for future life forms like us. The Cambrian explosion 550 million years ago, fast forward to 550 million years ago, and we witnessed the Cambrian explosion. Hundreds of new species emerged during this period, laying the foundation for every major animal group we know today, including early humans. The age of dinosaurs and their extinction 66 million years ago. For hundreds of millions of years, dinosaurs ruled the Earth, but 66 million years ago, a massive asteroid hit the planet, landing in present-day Mexico. This impact caused a chain reaction that wiped out the dinosaurs, allowing mammals to rise to prominence and eventually paving the way for us. The evolution of primates 40 million years ago, small furry mammals resembling today's rodents evolved into early primates. Their brains began to grow, and they developed an omnivorous diet of fruits and insects. This set the stage for the eventual evolution of apes and ultimately humans. The human-chimpanzee split around 8 million years ago, a common ancestor of both humans and chimpanzees split into two distinct species. Even though we share about 98 to 99% of our genes with chimps, our species continued to evolve in a different direction. Lucian bipedalism 3.2 million years ago, one of the most famous early human ancestors, is Lucy. Unlike modern apes, Lucy walked on two legs, a critical step in human evolution. Walking upright may have helped our ancestors forage for food or see over tall grasses, allowing them to adapt to life on the savanna. Tool used 2.6 million years ago by early humans were making simple tools from sharpened stones. Homo habilis, also known as handyman, was one of the first species to use these tools, primarily for scavenging leftover carcasses from larger predators. The control of fire 800,000 years ago, humans learned to control fire, a revolutionary skill. Fire provided warmth, protection from predators, and the ability to cook food. Cooking made meat easier to chew, leading to smaller jaws, which might be why many of us wear braces today. Building shelters and Homo heidelbergensis 400,000 years ago, humans began building shelters. Homo heidelbergensis, one of our ancestors, spread out of Africa and into Eurasia, eventually evolving into Neanderthals in Europe and Denisovans in Asia back in Africa. Homo sapiens, modern humans, were evolving. The first humans 200,000 years ago, Homo sapiens appeared. A key ancestor, known as mitochondrial Eve, lived around this time, and her DNA is present in every one of us today. Early humans faced countless challenges, from predators to disease, but they managed to survive. A near extinction 74,000 years ago, humanity nearly went extinct due to a supervolcano eruption that disrupted the climate. It's believed that only around 600 to 10,000 human adults survived during this period. But from these small groups, our species continued to grow and spread. Migration out of Africa 60,000 years ago, humans began migrating out of Africa, spreading across Asia, Europe, and eventually into the Americas. During their travels, Homo sapiens interbred with Neanderthals and Denisovans, inheriting traits like hair and skin adaptations from these ancient cousins. The agricultural revolution 12,000 years ago, the start of the agricultural revolution. Humans learned to farm, domesticate animals, and settle in permanent villages. This shift led to population growth, and by 1 AD, there were around 170 million people on Earth. The Industrial Revolution 250 years ago, the Industrial Revolution began, transforming human society from rural and agricultural to urban and industrial. Our population skyrocketed, and new technologies emerged, leading to the modern world we live in today. The future, as we continue to evolve, humanity's next step could be harnessing solar power or even exploring the stars. What does the future hold for our species? That's a question only time can answer, but one thing is clear: our journey from single-celled organisms to modern humans is far from over.